Welcome back, Dawn Hunters. I'm Captain William.
And I'm Yana.
We've gone from a trawler to a steel monohull and then a fiberglass catamaran.
And now, after 7 years living aboard, we finally have our dream boat.
Our 53-foot aluminium exploration catamaran is now being refit for our type of off-grid living.
This is part 2 of 2, where we continue our solar and lithium systems.
There's a lot of details here and technical information. Make sure you check out part 1 so you know what we're talking about in part 2.
And of course, remember to like and subscribe if you're not yet.
And comment.
Yes, leave us a comment.
There is no better way than a 3D drawing to depict all of the items in a system to get a total overview. So let's take a look at these items one by one. So let's break down what Dawn Hunter off-grid DC system is all about. For total, we have 31 kilowatts of lithium at 24 volt. We have 7,240 watts of solar. We have 2 DC generators off the PTO shaft to the engine, providing 16 kilowatts of power and 800 watts of wind. So let's start out with the solar on the port side deck. On the hardtop port side array, we have 4 300 watt flat panels for a total of 1,200 watt. And then we have the front deck port side bifacial 3x440 watts at 1,320 watts. This then feeds through a bus bar into the lithium battery bank that's on the port side, which are LF304 cells in an 8S2P configuration at 24 volts and controlled for safety with a 123 VMS system. Because the vessel does not have a typical generator, we've designed a DC brushless generator off of a PTO shaft that can run on either the port side or the starboard or both. But in this case, it's isolated to the port side from the generation standpoint. So at 10 kilowatt, 350 amp, 24 volt, we downrated this to an 8 kilowatt, 250 amp, 24 volt with a variable load, variable output, and a PTO drive shaft. To top it off, we also have the wind generator system on the port side, which is a 400 watt at 24 volt. Now we move to the starboard side, and on the starboard side of the vessel, we have the front deck solar array, which are 3 440 watt bifacial solar cells for 1,320 watts. We have the port hardtop array, which are 4 300 watt solar panels for 1,200 watts. And finally, we have the aft deck solar array, which consists of 5 440 watt bifacial panels for a total of 2,200 watts. These feed into the port side lithium bank, which is also an 8S2P that is the same as the other battery bank. So we have an A and a B battery bank system. As well, a redundant DC brushless generator system that is switched either from port or starboard or port and starboard, depending on the requirement. So there you have it, 31 kilowatts of power at 24 volts, 7,200 watts of solar, 16 kilowatt from DC generators, and 800 watts of wind. The boat does not require a shore power cord. Drastically have saved weight, space, diesel tank, exhaust, etc. by not adding an independent generator. Now to get all this connected and operating and into a test mode. So today I start building the battery bank that will store all the solar, wind, and generated energy. I'm using the LF304 batteries by EVE, and they will be in an 8 series 2 parallel configuration. Then I'll be utilizing the 123 BMS battery manager system, which will then go into a charging relay and a discharging relay that will measure both the current and the temperature of the cells. And this whole system will be multiplied times 2, so I will have a redundant system. So essentially, I will have an 8S2P and another 8S2P that then I can select whether I want that to be in parallel or running singular based on the load and the charging ratios. So off we go to building. I also have to build a retainer box to maintain its stability, so if we're bouncing around, the cells aren't moving around, and be doing the wiring. So over the next 2 days, this battery bank I will be building on the aft deck of the boat, and then each one of these will be installed into the watertight compartment in the actual front of the boat, about midsection. So the boat was designed with a forward bulkhead system that's watertight, and then a midsection bulkhead, and on the port and starboard side there's these watertight storage compartments, which is perfect for a battery bank on each side. So we've designed and built shelves out of aluminum. The batteries will go in here, and I'll still have room for dry goods, but essentially if anything was to happen with the batteries where they would burn or have an issue, they're not inside the boat, they would melt a hole through the aluminum and drop into the water, but it's not going to change the structure or the safety of the vessel. So you're looking at the starboard battery bank enclosure. After a lot of design and engineering and looking for the correct location, today I begin the mechanical portion of the battery build. And that is probably just about as important as the electrical side, because the batteries need to be properly secured, they need to be stationary, and they need to have access. So by utilizing aluminum, which is a light material to the boat, and utilizing extrusions that are actually from the window industry, the aluminum channel then fits perfectly with the shelf unit. So when we put them together, we now have a secure shelf system along with a very strong, rigid base for the batteries. And then we'll be clamping those together. So over the next, couple of hours, we're going to do the mechanical side of building this battery bank. There will be 2 of them, battery bank A and a battery bank B, which then electrically later on will go into how I'm going to switch and charge those and discharge those. So we begin the build. This is the very first bank, bank A. Each positive and negative needs to be lined up correctly, so when I connect the BMS 123s and I series and parallel these, the cells are in the correct orientation. Same as it exits, the plus and the minus needs to be in the correct orientation, so I have minimal cable runs. That all needs to be thought out prior. And now I'm going to put threaded rod and pull these together, not because I'm trying to compress them, but I want to keep any kind of movement from providing stress on top of the termination points of the bus bars in this case. Because this is an aluminum or aluminium shelf and design, I have to make sure that I isolate, so I've utilized actually electrical PVC that's going to isolate the cells from the actual frame. I've now added these sidebars so I can compress the cells and hold them actually in a stable position. And after I get this side done, then I'll move on to the other side. So it'll all be pulled together like one complete brick. And then I can build the acrylic cover and around, so it won't be totally sealed, it'll breathe, but I'll be able to see what's going on inside the cells. So mechanically, the battery system is now temporarily secure. Spacers, washers, aluminum frame, and the top and the bottom systems are in place. So now it's time to tighten them down and start doing measurements. So battery bank A mechanically is now finished. I have the bottom shelf bracket, the aluminum bottom plate. I've got the mid bracket, all which are compressing the cells, but it's not for a compression of the actual requirement. It's more a compression mechanically so that when I mount the bus bars, there's no movement into batteries whatsoever. There's isolation between the items, so if there's any kind of ever a short, it's not going to actually go anywhere. So this battery bank is now complete, ready to get the BMS on top. Again, for you guys just joining, these are LF304s, and it is a 8 in series, 2 in parallel. So it'd be an 8S2P for battery bank A, and there'll be another 8S2P for battery bank B. All the parts are cut for the second one. The R&D is done for the first one, so the second one should go along a lot faster. Now I've got to get the welder hooked up because I have to do the welding so this can go into the front locker, which is also a watertight locker, but it's exterior of the vessel. So if we do have any issues, it's not inside the boat. Testing over the last 3 months, I have actually had the opportunity, both good and bad, to test several flat panel flexible styles, the bifacial monocrystalline solar panels, and encountered several very important facts. And this is specific to the aluminium vessel. I can't speak for fiberglass and other vessels because I can make assumptions, but the facts are here. After a couple of months of reading temperatures, reading voltage outputs, efficiencies, my plan to put flexible on the upper deck, aft deck, and on the hardtop have been foiled. Had some delamination issues, huge temperature fluctuations. Most of all, temperatures here in the tropics in some cases exceed on the top almost 76 C. The aluminium, although it's a heat sink and it pulls that temperature in, it also distributes it across the whole upper deck, and thus we start with a thermal runaway issue. Sunwear, other flat panel flexible, and the bifacial. As we'll walk around, I'll show you that I have determined to date the best is to go with the bifacial rigids. It gives airflow underneath. It gives solar and sun protection from the actual upper deck. The output is less affected by heat. The output is far greater in cloudy days and days of haze. So I'm finding that the flat panel compared to a flexible, if I've got, for instance, 2,000 watts of flexible and I have 2,000 watts of flat panel, I'm actually getting 80% on the monocrystalline, and I'm only getting 30 to 35% on the flat panel. I guess we'll do a little less walking on the upper deck and a lot more producing of solar. I've also changed the design on the upper hardtop. I removed both of those, I'm lowering them, but I removed the rigid solar panels that were there, and I'm laying out that location with a canvas cover over the aluminum frame, putting the flexibles in that location because they'll be able to cool. They'll also be in a location that if something should go wrong, it's not going to really affect the boat at all. So I'm going to give you some more facts based on real live numbers and testing. After owning so many boats and trying 48 volt, 24 volt, 12 volt, AC generators, wind generators, solar, hydro generators, I guess over the last 30 years, so many of the technologies have evolved and changed. But the one key factor, I say off-grid life or off-grid use, whether it's a cabin, camper, motorhome, or a boat, is everything has moved from a generator that uses gasoline or diesel to lithium batteries. And the reason for that is if you can store energy from the sun or you can store energy from the wind, then the sun and the wind is providing you power that is essentially free. Well, nothing's free. You still have to buy the components to store it. But as battery technology evolves, predominantly because of the space program, military programs, the automatic car, electric car programs, scooters, power tools, the lithium market has evolved to where the key in the heart of a vessel today needs to be the storage system. What you bring to that battery bank, whether it be solar, wind, generator, charger, shore power, hydro, all of the various types of power that can be created, if they're not able to be stored, you must be able to create them on demand. And so on a boat, that's not always so easy. Or if it is, it's very noisy. It takes away from the whole solitude and peace and quiet of being at anchor somewhere. So storage is the key in the heart. And then what you bring into it and what you take out of it becomes the factors that you need to calculate and how big that storage should be. But I've learned the hard way that you depend on one storage system and it's so convenient and you get, I guess, lackadaisical, that when that system goes down, you're done. Nothing is working. Bilge pumps, instruments, cooking, even running water through a pump to fill a glass of water through a filter is done for. What I've done in this vessel is I have designed a dual battery bank, an A and a B. And for simplicity, let's call it a port and a starboard. So the way that this boat is wired now and the way that it will operate is that I have a complete port side storage, solar, generation, load bank, and I have a complete starboard duplicate system. And just like when you have a pair of engines in a catamaran or a pair of generators, I can switch between A and B, or in this case starboard port, or I can join A and B starboard port, or I can charge alternately which way I need to charge them or discharge them. So I have a fully redundant system. In that case, I have the ability to turn the lights off at night and know that if something goes wrong, I have a plan B. Just like when you're parachuting, you don't jump out of the plane with one parachute and hope that that's going to open. We have now completed the bank A and bank B mechanically. It's been designed. It's not a compression system. It's a system that keeps the cells in place from vibrating, moving around. And then these are going to be installed in the port and starboard front watertight compartments and then wired directly into the house system. So the key here is typical inverter that you would be using is very small, and the charging system is all DC. So the solar system goes into MPPT controllers and then converts that to DC. I have designed a PTO takeoff DC generator off of the port side engine and off the starboard side engine, which can then be ramped up or down based on the load required and provide voltage to battery bank A or B. Or if need, both sides can run into one bank. So once again, I have the complete flexibility of changing a couple manual switches and deciding where the power goes and where it comes from. So now we're going to start wiring these guys together, testing them on the bench, take it all apart, and then put them back together down in the lower two exterior storage locations. And we're doing that because they're kind of heavy for moving around. It's much easier to sit inside there and wire them than it is to try and move this battery bank around. Off we go to the bus bars, to the BMS wiring, and then putting them in place, and then we'll complete the wiring. All of this to store that sun power and that power when we are running or motor sailing, and that someday later I can always add a couple of hydro generators if I want. The wind generator systems are being installed, and I have to decide how to properly wire those in. That's another little trick for another day. I'm using the 123 BMS system. That consists of a beginning board, it consists of an end board, and then each positive cell gets an in-between board. And these systems monitor the voltage at each cell and the temperature of each termination point. In the event there's an issue between voltage or temperature, the BMS will shut down immediately and not allow any discharge or any charge. At the same time, I'm monitoring the charge current and the discharge current of each one of these modules. So if it overcharges or if it is pulling too many amps of current on a draw, it's also going to shut down. Now this is linked into the Victron, so the Victron can tell us what's going on, but it doesn't require the Victron to shut the system down. Now that means that I have currently 8 cells in series and then both in parallel, so it's a 2P8S, which gives me 12 volts and 12 volts in series parallel combination to give me 24 volts. So I've got 24 volts at approximately 16 kilowatt hours on battery bank A and the same on battery bank B. Each of those being controlled separately and independently of their own BMS system. That way we have safety redundancy, and the BMS 123 has a cell top-off circuit, so it's automatically monitoring each cell, and if one cell drops a little bit low, it'll take voltage from the other cell and provide voltage to it, so we're always going to be top and top balanced. All of this you can see on the app. of a phone or of an iPad so you can see real time the temperature and the voltage of every single one of these cell banks without using a gun. Pretty neat stuff. You can check the links below. If you want more data and information, make sure that you hit me up on Patreon and I can answer more questions that are more technical. This is just a matter of getting the batteries together, getting the right solar together, connecting it, and no shore power cord and no noise from a noisy diesel generator. Solar has become a real pain in the ass trying to come up with different designs and different locations. This is one side of the hardtop. There's a port and starboard side, and so I've decided to utilize the flexibles on this location because they'll still be cooled with air. If there's a fire or anything happens, they're not going to affect the rest of the boat. It's also going to reduce a lot of weight above the water line because there were 4 really heavy panels up here. That's all going to be removed. We'll be laying over old sail, recycled, and then putting the panels on top of that. Well, after spending all this time testing flat panel, flexible panel, panels you can walk on, and now going with the bifacials on the upper deck, it solved 95% of my wiring issues because now I have room to run the wires underneath. There's an air gap between the solar panel and the top of the boat, so it acts as an isolation for the heat. And now I can run the parallel wires directly from the last panel where the mast is and down inside, so I can run each side in a parallel position. Then I can keep the voltage manageable, and if there's any type of shadowing from the mast, the boom, or anything else, it's not going to affect all the panels. It's going to affect the panel that's shaded. I cut the hardtop off. It had 2 solar panels of around 300 watts each on each side, and I'm now modifying that and putting the flat panels there, so if I do have a problem with them, they will be sitting on the very top of the boat, and they are going to be sitting on top of a used sail because I'm going to have a sail sewn, and that's going to be the cover over the top to keep the weight now as low as possible because the mast and the boom is quite large on this rig. Getting weight lowered to the water line has been the key in changing the actual CG of this vessel. Let's go take a look at that hardtop design that looks like a solar factory. So here we have the bones of the original hardtop that had solars built in, and it's quite heavy. By putting the flexibles on top, we can really reduce the weight, and then the structure does not have to be as rigid. It was also very high to where the boom was actually intersecting with it on certain points of sail. So I've lowered this down so the boom is no longer going to have a collision process. Let's go take a look at that hardtop now with all the different solar panel layouts. Here we go. By using the flat panels and redesigning the frame a little bit, I'm going to reduce the weight by over 50%. If you look here, we're going to have 4 200-watt solar panels and then 3 100-watt solar panels on both the port and the starboard side with, again, 50% weight reduction. That means that I get a lot more surface area for solar because I want to grab as much sun as possible. I did discover that an excellent location for these flat panels, I can fold them up, attach them to a old sail, pull them out of the sail locker, and lay them across the front of the net. So when we're at anchor, they'll be able to easily attach. We'll still have the front of the net available for anchoring, pulling the rode, and doing other things. But this is an excellent location because they can breathe. Get air from below, they're still producing output. So on the net, you've got a very high output as compared to laying them flat in some other location. So here's going to be additional solar that I'll be able to just plug in when we're at anchor and when we need that extra boost. Finally, the batteries are in their resting place. Had to wire them all, then disconnect it all, move it in place, and then put mounting brackets so that they're not only secure, but even if the vessel was to violently move or even go upside down, the batteries are going to definitely stay in place. Let's go take a look at their new homes. Starboard and a port side compartment, and battery bank A and battery bank B are now installed.